Hi guys, and finally we're about to start building our blockchain. So we will build this blockchain in two parts. First, part one, building the blockchain. So we will build just the architecture of the blockchain. And in part two, we'll make some functions, two functions actually, to get the state of the blockchain, to display it in our Postman user-friendly interface. And another function to mine, of course, a new block in our blockchain. And therefore, today we're going to start with part one. But just before we start with part one, as you can notice, I imported the libraries that we will need to make these two parts. First, the datetime library, because each block will have its own timestamp, which is the exact date the block is created, is mined. Then, of course, we'll use the essential hashlib library, which we will use to hash the blocks. So we will work with hash functions. Then we will import JSON, the JSON library, because we will use the dumps function from this library to encode the blocks before we hash them. And finally, we will, of course, use Flask that we installed in the previous tutorial. And from this Flask library, we will import the Flask class, because we will create actually an object of the Flask class, which will be the web application itself, and JSONify. JSONify is a function we'll use to return the messages in Postman when we interact with our blockchain. So, for example, when we make the request to get the actual state of the blockchain, to display the whole blockchain in Postman, well, we will use JSONify to display the response of the request. And same when we mine a new block to add it to the blockchain, well, we will also use this JSONify function to return the key informations of this new block that was just mined in the JSON format. So you will understand that better once we start working with JSON files, but basically we will return in the JSON format the index of this new block, the proof of this new block, and the previous hash attached to this new block. And also a little message to say that the block was just mined. Alright, so now let's start implementing part one, building a blockchain. So, how are we going to build that blockchain? We have several options. The first option would be to make several functions and use afterwards the function to build the blockchain. But that's not the best option, and that's not the mindset that a developer should have when building something huge. A blockchain is something huge. It's supposed to be a decentralized network that is all over the world with tons of blocks mined one after the other, and therefore that's not the best way. The best way to build that kind of system is with a class. You can build anything with a class. You can build a self-driving car, as we did in our AI A to Z course. You can build a sophisticated program, whatever you want. And the reason for this is because a class basically contains some advanced structure in which you can include properties, functions, tools, methods, all of them interacting with what you want to build. So for example, let's take the self-driving car example. If we want to make a class for a self-driving car, well, we would define in the class all the properties of the self-driving car, plus some methods, like for example, move forward, move backward, go left, go right, accelerate, brake, whatever. You can put all these actions into some methods that you include in the class. So that's very practical when you want to build that kind of advanced system, and that's exactly what we'll use for our blockchain. And that is why right now I'm going to start with class, because to define a class in Python, you need to start with class, and then you just add the name of the class. And since we're building a blockchain, the name of the class will simply be blockchain. Alright, and then colon, and here we go inside the class. So what will we define exactly inside this class? Well, that's basically all the components of a blockchain, all the pillars of the blockchain. So we will of course include the genesis block, then we will of course initialize a chain that will be in the init function, then we will make a create block function to add a new block, and which will of course be used to mine a block later on. And then we'll add a couple more tools to make sure our blockchain is solid. That we have a solid blockchain that cannot be hacked or broken. And so we will include all this in this class, and that's only what we'll be doing in part one. This part one, building a blockchain, will only contain this class. Alright, so if you're ready, let's do this. And when we work with a class, we always start with the init method. So since this is like a function, we start with def, then double underscore init and double underscore again. And this init method always takes one same argument, which is self. And self will refer to the object that we create once the class is made. Because once we're done making the class, we will create an instance object of this class, which will be the blockchain itself. And that's another great purpose of making a class. It's that when you make a class, then you can create as many objects as you want. And this self here, we will use it to specify that the variables we'll introduce, preceded by self, will refer to the variables of the object. Alright, so now let's initialize our blockchain. So to do this, of course, we will need to initialize the chain that will contain the blocks. And so I'm going to introduce a new variable here that will be self.chain. And this will be simply the chain in the blockchain, the chain containing the blocks. The blocks are not there yet, but we're going to make them soon. So self.chain, and as you might guess, this will simply be a list containing the different blocks. And that's exactly how you initialize a list in Python with square brackets. And then the other compulsory thing that we have to do to initialize our blockchain is to create the Genesis block. The Genesis block is the first block of the blockchain. And to create it, we're going to use a function that we will make in the next tutorial, and that we'll call the createBlock method. So to create this Genesis block, the first block of the blockchain, well, I'm going to call this future function that we'll make, which is createBlock. And this function is going to take two arguments. The first one is the proof, because each block of the blockchain will have its own proof. And here we can choose an arbitrary value, and a common practice is to start with 1, a proof of 1. And then the second argument is another key that each block will have, which is the previous hash. That is the link with the previous block. However, here this is the Genesis block, so this is the first block of the blockchain, and therefore there is no previous hash. And that's why we also need to give an arbitrary value, and a common practice is to choose a previous hash of 0. You could also choose 1, this is an arbitrary value, but again, a common practice is to choose 0, and you have to put it in quotes, because we will use the SHA-256 function from the hashlib library, which can only accept encoded strings. So that's why we have to put that in quotes, and here we go. We have initialized our blockchain. So far we only have the chain itself, initialized as an empty list, and the Genesis block that we create thanks to this createBlock function that we'll make in the next tutorial. Until then, enjoy blockchains!